What is a graph? In this video, we are going to introduce you to the mathematical definition of a graph and its many types. But first, we need to define what we mean by graphs in general. Then we will discuss in details the definition of symbolic graph. Then we will discuss what is a complete graph, empty graph, and finally, line graph. Informally, a graph is a bunch of dots and lines where the lines connect some pairs of dots. The following figure is an example of a graph with 9 nodes and 8 edges. Graphs are ubiquitous in computer science because they provide a handy way to represent a relationship between pairs of objects. The objects represent items of interest such as programs, people, and we place an edge between a pair of nodes if they are related in a certain way. For example, an edge between a pair of people might indicate that they like or they don't like each other. An edge between a pair of courses might indicate that one needs to be taken before the other. The first definition is going to be about symbolic graphs. A symbolic graph G consists of a non-empty set V called the vertices, and those are the nodes of G, and a set of E, which is the edges, and they contains two element subset of V. The members of E are called the edges of G, and we write G as a combination of V and E. The vertices correspond to the dots in the figure, and the edges correspond to the lines. The graph in the figure is expressed mathematically as G equal the combination of V and E, where V is the subset A, B, C, D, E, F, G, H, and I. Now the edges are two element subset, so the first edge between node A and node B is denoted by the subset A and B. Another subset, which is denoting the relationship between A and C, is denoted by A and C. You need to note that A and B as an edge and B and A are different descriptions of the same edge, since sets are unordered. In this case, in this graph in the figure, we have 9 nodes and 8 edges. The second definition is going to be describing symbolic graph. So two vertices in a symbolic graph are said to be adjacent if they are joined by an edge, and an edge is said to be incident to the vertices it joins. The number of edges incident to a vertices F is called the degree of the vertex and is denoted by the function degree of V. The degree of a vertex is equal the number of vertices adjacent to it. In the symbolic graph shown in the figure below, we can observe the following. Vertex A is adjacent to B and B is adjacent to D, and the edge A and C is incident to a vertex A and C. Vertex H has a degree of 1 because it's only connected to another node. D has a degree of 2 and degree of E equal 3 because E is connected to F, C, and G. It is possible for a vertex to have a degree of 0, in which case it is not adjacent to any other vertices. A symbolic graph does not need to have any edges at all. In this case, the degree of every vertex is 0, but it does need to have at least one vertex. Symbolic graphs do not have any self-loops, since an edge is defined to be a set of two vertices. In addition, there is at most one edge between any pair of vertices in a symbolic graph. In other words, a symbolic graph does not contain multi-edges or multiple edges. That is because E is a set. Lastly and most importantly, symbolic graphs do not contain directed edges, that is, edges of the form A and B instead of the subset A and B. Complete graphs. What we mean by complete graphs? In this fashion, the complete graph on n vertices denoted by k of n and has an edge between every two vertices for a total number of n multiplied by n minus 1 divided by 2. And this is shown in the following figure. Figure 2 is giving you the complete graph on 5 nodes, and we call this graph k of 5. The empty graph has no edges at all. For example, the empty graph with 5 nodes is shown in the following figure number 3. There is 5 nodes and they are not connected with each other, which means they don't have any relationship between each other. Finally, line graph. The n-node graph containing n-1 edges in a sequence is known as the line graph L of n. More formally, L of n is a combination of V and E, where V equal the set V1 up to Vn and E is two-element subset between V1 and V2 up to Vn minus 1 and Vn. Example of line graph. L5 is an example of 5 nodes in the graph. So L5 line graph is displayed in figure 4. If we add the edge V1, V2 to line graph L of n, we get the graph C of n, which consists of a simple cycle. For example, if we add the edge V1, V2 to L5 shown in the above figure, this results in C5 as illustrated in figure 5. So basically in this video we have covered the definition of symbolic graphs, complete graphs, empty graphs, and line graphs. In next video we will cover the following: introduction to graphs, graph taxonomy, and graph models.